So today we are just talking about equations of a line, and we're going to focus on most of the types of lines today. We're going to skip one today. But the types of equations we need to know, there's one called point gradient form, or you might also know it as point slope form. Okay. There's one called standard form. You might also know it as, we'll just put that in point slope form, as general form. I think we call it standard form mostly, but general form is another name for it. So I just want to make sure I'm covering both. And then there's the equation. Well, let's go and do that in a different color, actually. So there's point slope form, standard form, or like I said, general form. And then there's the equation of a horizontal line and equation of a vertical line. Those are the ones we're going to focus on today. So first one, point slope form. That's a really good one for if you know 2 points, you can find the slope. All right. So if you're given 2 points, and then what you can do is you can do y minus y sub 1 equals slope times x minus x sub 1. That's point slope form. We don't use it a lot, but it's really useful if I give you 2 points on a graph. You can find the slope, and then you can write an equation pretty quickly for it. And then it simplifies into slope-intercept form, which slope-intercept form is the one we're not going to really talk about today. We'll save that one for Thursday. But we do already know slope-intercept form, so hopefully it's not too crazy that we're skipping it right now. The next one is general form, which is when x and y are on the same side of the equation. You might have something like ax plus by plus c, everything equals 0. That's general form or standard form. All right, so everything's on one side of the equation, and then it's equals 0. Okay. And then we have equation of a horizontal line. That's just y equals c. And it's always a y equals for a horizontal line. If I were to sketch a graph real quick, that would be my horizontal line on it. And then equation of a vertical line. Is always going to be x equals. In this case, x equals c, or we can always just say x equals. Those are the 4 equations for today. Like I said, nothing big or groundbreaking there. We've done all this before. And these are just reminders of how we write equations. We always want to write equations as x equals or y equals. Okay. And what we're going to be asked to do today is find the equations of lines for stuff given. And for like example A here, it says here's a slope of 3 or gradient of 3, and it passes through the point 1 comma 7. So this is where point slope form comes in. We do y minus 7 equals our slope, and then x minus 1. And the tricky part about this, I guess, is I put the 1 and the 7 in parentheses. And I do that just in case there's a negative. Because if it's a negative 7, I do y minus negative 7. And I don't want to forget that. Or I do x minus negative 1 if it was a negative 1. So here I put them in parentheses because then the next step would be just to remove the parentheses and rewrite it as y minus 7 equals 3 times x minus 1. And that's how I can leave it. That's it. That's the equation of a line, and that's in point slope form right there. Now, if I wanted to graph that line, I might need to change the equation into slope-intercept form. All right? But for right now, I can just leave it at that. Okay? That would be example A there. Example B gives me 2 points. Passes through the point A at 1 comma 3 and B at 2 comma 5. So the first thing I'd want to do for example B is go ahead and find the slope. Rise over run. So subtract the y values. 5 minus 3 is 2. Subtract the x values. And I get a slope of 2. And then the second part, once I have that done, now I can go ahead and write an equation. And it doesn't matter which one I use, as long as I use both values from that equation. So I'll do y minus 5 equals 2 times x minus 2. And that's just because in part, the second part, I was using the 5 and the 2 from that equation. And then the slope was positive 2 from over here. That's how I can write an equation in point slope form. That's going to be a lot faster than writing an equation in slope intercept form, because all I have to do is to write these down is just pick a point. And so write down these equations in point gradient form, which we already did. Y minus 7 equals 3 times x minus 1. And then the second one was y minus 5 equals 2 times x minus 2. Actually, I'll do the second one in red still. And then the last part is to go ahead and graph them. So now, if I want to graph them, I do need to solve for y. So that's where I can go ahead and say, let's distribute this. And we'll have y minus 7 equals 3x minus 3. And then add 7 to both sides. Y equals 3x plus 4. And that's going to make it a lot easier to plug it into my calculator to graph once I have a y equals equation. For the red one, distribute, I'm going to get y minus 5 equals 2x minus 4. Add 5 to both sides, and I get y equals 2x plus 1. And now that's going to be a lot simpler to graph as well. So when I graph the two lines, I can plug it into my calculator and graph it. But the other nice thing about being in this format now is if I create a scale of 1 here, I just go 3x plus 4. I know 4 is the intercept, and then I go up 3, 1, 2, 3 over 1, up 3 over 1. And I can do the same thing in the opposite direction, down 3 over 1, down 3 over 1, down 3 over 1. And then I can sketch my line. and put arrows on it. And if I'm able to do this in separate colors, awesome. If I'm not able to do it in separate colors, I definitely want to label my lines and say, okay, that line right there is 3x plus 4. And then when I sketch the second line, again, and put my arrows on it, but I do want to note, hey, that line is 2x plus 1. And I write that down just because I want to distinguish between my two lines, especially if I don't have different colors, if I have to do everything in the same color. Always important to label both of your lines on your graph. Okay, so point slope form serves the purpose in that it's really easy to write an equation for it. And then slope intercept form, I think, serves the purpose of I can identify the y-intercept really quickly, and I think it makes it really easy to draw the graph because I can start at the y-intercept and then I can sketch my slope from there to make my straight line. But if you have a graphing calculator, you can always graph it on your calculator and then just sketch from your calculator as well, which is perfectly fine. All right. So now example 12 here is given in standard form or general form. And it says go ahead and draw the line for 3x plus y plus 3 equals 0. For this one, you're going to want to solve for y in order to graph it. So start by, you can either subtract 3x or subtract 3 from both sides. And then you'll do the next subtraction. So negative 3x minus 3. For this one, I'll just go ahead and put a scale of 1 on there again. Count and 1 in each direction. And I know my y-intercept is negative 3. And then my slope is going to be negative 3. 1, 2, 3. 1, 2, 3. And go in the opposite direction. 1, 2, 3. All right, and then I can sketch my line. Okay, so whenever I want to draw a line, it's going to be easiest to switch it into that slope-intercept form. So I feel like general form or standard form is kind of the most useless of them. I think point-slope form serves a purpose, and I think slope-intercept form serves a purpose. And general form I don't really feel like has much of a purpose. It's just kind of a tough one to work with. So it's best just to switch it into a different form that we can recognize and then work with it from there. Okay. All right, so that's example 12 for us. Let's see. What's up? All right, that was interesting. Okay, so example 13 says points A and B lie on the straight line boundary between two plots of land. Write the equation of the line passing through points A and B, and then a tree is located at point C, 25, 30. Determine whether the tree is on the boundary line or not. So this happens sometimes where we're given a graph and we have to identify the equation based on the graph. So let's start by identifying where points A and B are. point A is at 6, 8. Point B is at 12, 10. So first thing I can do is go ahead and figure out what the slope's going to be. And we'll do rise over run. So the y values over the x values. Okay. So I end up getting a slope of 1/3. All right, the next thing I'm going to do, once I figure out that slope, I can go ahead and I'll use point A, which is 6, 8. I'll go ahead and say y minus 8 equals 1/3 x minus 6. Just make sure that I put the x in the right spot and put the y in the right spot. And now I've got an equation of a boundary line. And then that's the first part, writing the equation. The next part says, hey, there's a point C here, 25, 30. Determine whether that tree's on the boundary line. All we need to do for this is plug in 30 minus 8 equals 1/3 times 25 minus 6. Okay, plug in your x and y's. And we'll find out if that tree is on the boundary line for us. Okay. And if it is, then we should get the two sides being equal to each other. And I end up getting, let's see, 30 minus 8 is 22. And then on the other side, I get 25 minus 6 is 19, so I get 1/3 of 19, which is, I get like 22 is equal to 6 1/3, which is not true. They're not equal. So just that simple to say that these are not on, that this is not on the line. Okay. Point C is not on the line. All right. That's the idea for that example there. We can just use, again, that point slope form, just plug in for x and y. 30 and 25, that's where they came from there.
Where did the 6.3 come from?
I did 25 minus 6, that's 19. And then I did 19 times 1/3. And that came out to 6 1/3. Okay?
Okay, thanks.
Yeah, of course, no problem. All right. Last example today, and then I'll let you go. It says a sailboat is moving along a straight line with this equation negative 2.5 x plus y equals 3. Determine whether a tanker located at point A is on the trajectory of the sailboat. So again, this one, whenever we have the equation already, we can just plug straight in. Always use parentheses. This is a great example where using parentheses is good because it's going to be plus a negative 2. And then I could technically rewrite it and say, okay, that's 2.5 times 3 minus 2 equals 3 when I want to get rid of those parentheses. And I do negative 2.5 times 3 is negative 7.5. And I end up getting negative 9.5 equals 3, which we know is not true. So the tanker is not on trajectory to hit the sailboat. So all you're looking for here, again, is are the two sides equal? Since one of the sides equals 3, does the other side also equal 3? If the answer is no, then you're okay. And then part B says find the exact y coordinate of the point of arrival for the sailing boat if the x coordinate is 10. So now you have negative 2.5 times 10 plus y equals 3, and we are just solving for y. That's the last part here. All right, so go ahead and figure out what y is. Take a second to do that, and then we'll take a look at it. All right, so you get negative 2.5 times 10, you should get negative 25 plus y equals 3. Add 25 to both sides. I ended up with like y equals 28. So that's our point of arrival then, would just be 10 comma 28, since that's where they said if the x value is 10 at the point of arrival. So that would be it. All right, so hopefully not too bad today. Tomorrow's gonna be graded assignment day. Thursday we're going to talk more about slope-intercept form, or the book calls it gradient-intercept form instead. But that's our plan for Thursday.